Afternoon, guys. How do you do? I am going to explain one of the last issues related to the immunity in our body, the immunity system. Now, the defense system. I have already posted some videos on diseases, and other issues in non-specific um, defenses, but today we are going to talk about the immunity system. Basically the white cells. I have been searching through YouTube and many other places, but none of the videos have satisfied me enough. So uh, let me take a few minutes, maybe a little bit longer, to explain this issue from my point of view. What is immunity? Immunity is not to be affected by something. Okay, if I am immune, it means nothing will affect me. As we have been already seeing, because this is not the first video you will see, there are many different pathogens that could infect our body. Okay, and the idea is that we can avoid that infection, or else, if infection has already happened, fight those microorganisms and finally destroy them. And most of all, be prepared for further infections. Okay, so if it's all about being foreign, avoiding foreign infections, then the point is that we have to know, I mean, our cells must know which things are foreign and which things are not. Okay, that is, every cell carries its own identification. Okay, every cell on its surface, and actually in the inside as well, carries its own identification, the same as we could carry our DNA. Okay, and that DNA carries information about the organism, right? That is what we call antigens. Okay, antigens. You will see about that in a video. Basically, antigens are mostly proteins that are found in in every living cell. Okay, remember that cells are made of proteins. Every living cell is made of proteins. Even viruses are made of proteins. Okay, so every living cell has its own identification. Um, our immunity system, our defense system, is in charge of detecting that the foreign cells and attacking them, right? So I'm going to start playing a little bit, because actually we're talking about an army, all right? We're talking about defense, right? The same as in a country has got a, police, the army, the navy, in our country, the gendarmeria, prefectura. Well, okay. Imagine all those are together, and the only difference between them is the specialization in a different part of the body, or in different ways of fighting, in different against different organisms, if you wish. All right, but they all basically work more or less in the same way. In all those forces, there are two arms. Two arms. One of them, gentlemen, is the infantry. Okay. Yes, I have stolen the toy soldiers from my son. Okay. The infantry. That is soldiers that fight face to face. Okay. In the front. All right. And they are. Uh, where do we find these white cells in the body? Uh, everywhere, everywhere. Okay, because if they are in charge of uh, fighting face to face, they must be everywhere. Everywhere an organism might invade the body, might infect the body, and the body might be infected not only through the skin, but through the digestive system, and all the digestive system going through the breathing system, and then I will show you a couple of examples of the sort, right? Real examples and microscopic pictures about them, right? What is the characteristic of this army? I insist, they fight face to face. And as you can see here, they have different ways to fight face to face. I mean, they have long arms, they have short arms, they have mechanisms to detect the enemy, etc., etc., and even mechanisms to communicate with each other. All right, very good. Those in our body are what we call the phagocytes, pH phagocytes, right? But then in this army, we have the second arm that is the artillery, okay? A little bit old fashioned artillery, but it works anyway, all right? Uh, Actually, this is, we're going to leave the cannons beside because uh, the modern artillery is more based more than in shooting bombs, okay, or big bullets. Yes, it is in charge of shooting missiles, right? And that is the point, right? Shooting missiles. That is, they could be in a place, right, far from the front, far from the battle, okay, ready to shoot their missiles directed against the enemy, right? All right. So these, the artillery in our body is what we call the lymphocytes. And again, there are different types of lymphocytes, so it pays to include a couple of cannons and things. Yeah, cannons and things. So because there are different types of artillery. There are different types of lymphocytes. Are there as there are different types of phagocytes, which is not our issue so far. The only thing we have to know is that phagocytes work in one way, uh, lymphocytes work in another. So how does this work? We said that the lymphocytes, we're going to move them about, the lymphocytes, the artillery, because they are in the headquarters. Okay, we will show you, I will show you in a while where the headquarters are. The headquarters are hidden in the body, obviously. Okay, not in the front. Remember what we saw about arteries. Arteries are exposed, are protected inside. Well, the same happens with the artillery, with the lymphocytes, right? But the phagocytes are found everywhere, not only in blood. Actually, it is quite a mistake to say white blood cells because white cells are found everywhere, especially phagocytes. And they have the capacity to squeeze out of the blood and move everywhere in the tissue, squeezing among the tissues in the body. Okay? So by doing that, eventually there is a wound, okay, in a certain part of the body, and infantry that are mucking around there, yes, that are in patrol, okay, might find something that must have come into the body, all right, something that is foreign, something that cannot show the correct identification, okay, the one that says you, right? So what do? They engulf, all right? They engulf. So far, they work fast, but not so violently as it sounds. They engulf the organism, yes. They keep it inside and then destroy it, but not completely. They destroy it until they find the identification, the antigen, okay? And they keep it and they will take it to the lymphocytes. And here comes the question, where are, let me push the army aside, where are the lymphocytes, okay? And here I'm going to start sharing my my screen, okay, so that I can show you, no, not this, but this, okay? This is the lymphatic system. It's quite a simple view of the lymphatic system, uh, but mostly I want to show you that it's a series of pipes, okay? If you take a look, it's a series of pipes that run along the body, right? The same as arteries and veins. Well, basically they are vessels, okay? They are much more similar to veins, okay? Because their walls are rather thin, because the substances that flow through them flow at a very low pressure. And what are they like? If you take a look, there is not a circuit here like in the circulatory system. They are just one-way pipes, okay, that come from all your body, collecting debris, all right, into the circulatory system. If you take a look, all the pipes, this is not very well shown in this picture, but the what has to be shown is shown. They collect all together into a tube that is very, very thick here in the thorax that is called the thoracic tube. And that tube ends directly in one of the most important veins in your circulatory system. So eventually, all these liquids will collect into the circulatory system. Okay. Well, there is a neighbor that has started listening to music. I'm so sorry. I don't like the music, but let's go on. So all this debris is collected into the circulatory system. Basically, it's a sewage, okay, system, all right? All the debris that is collected in the body. Now, can you see that along the pipes, along the tubes, there are circles? There are circles. Those are the headquarters. Those are what we call the lymph nodes, okay? Nodes that you can find, for example, in your neck, that you can find in your armpits, that you can find in other places in your body. And typically, your doctor, yes, when he checks you, will check if those nodes are okay. What does it mean that they're okay? That nothing is going on there, all right? If they are inflamed, if they are swollen, if they hurt, it means something is going on, right? Let me show you a couple of pictures. Remember this picture of an artery with a thick wall? Now take a look at that blue patch over there. That blue patch is nothing but a lymphatic node, okay? And the blue stuff that is filled in is the thousands of nuclei of the lymphocytes. If you remember from the homework, lymphocytes, there is another one there at the top, lymphocytes uh, have a very large nucleus and very little cytoplasm. Here, this is a picture of a lung we will see very soon. And here in the middle of the tissue, a lymphatic node. Does it make sense? Of course, the lungs are very much exposed to the outside. So the headquarters are very close there, all right? So what happens there? Remember the soldier that was looking for patrolling and found some foreign organism, has phagocyted that foreign organism and has kept the identification. Through the lymphatic vessels, wherever it was, through the lymphatic vessels, through the sewers, it will go to the lymphatic nodes. And in the lymphatic nodes, it will find the lymphocytes. It will find the lymphocytes and it will look for one lymphocyte who recognizes this identification. Because proteins can be very variated, but they are not infinite. So there are a lot of type of proteins, but not infinite. And we have one lymphocyte for each of those uh, identification, for each of those antigens, right? And what will the lymphocyte do? Produce missiles against the identification. Those missiles are called antibodies. I don't show you any picture here because the other videos that you can watch will show you clearly what I mean, okay? So the lymphocytes from the headquarters, yes, will do a couple of things. The first thing they will do is reproduce. They will make a lot of, sorry for the color, they will make a lot of lymphocytes of the same type that recognize the same antigen and produce the same antibody. They will shoot those antibodies into the blood, and those antibodies will catch any organism of the same sort, because usually a bacterium alone, a virus alone does not come into the body. It's hundreds of them at the same time. Yes, in the case of a coronavirus, for example, when you might be infected, you will be infected with thousands of viruses. Okay, thousands of viruses. When somebody coughs or sneezes, it spreads out thousands and thousands of viruses at the same time. So, and now let me make a short revision of what we have been saying. Then the bacterium that are here, these green rods, yes, with their antigens, with their identification, are caught by a macrophage. Macrophages are the phagocytes, okay? By the phagocytes, they engulf it, they destroy it, and they keep the antigen. They take the antigen to the lymphocytes, okay? Forget about this T helper cell because obviously it's a helper and it's secondary. The B cells are what we call the lymphocytes, okay? And they will start producing antibodies. There we have these green little things, little Y-shaped things that are the antibodies. At the same time, uh, as the antibodies stick to the bacteria, that will make our phagocyte army mad, okay? And they will start shooting without asking, all right? They will destroy those microorganisms in any way they can, all right? Personally. After the infection, yes, after the infection, all this might have taken around 2 weeks. What if the microorganism kills you before? Well, goodbye, you're dead. That's why we need vaccines. But after the infection, there will be memory cells, right? That is, these lymphocytes that haven't been fighting, or some of the lymphocytes that haven't been fighting, will turn into memory cells. That is, cells that produce the same antibodies, okay, that will stay going back to the headquarters or circulating around the blood, yes, and they will be ready for a next infection. In the next infection, the memory cells will be so many that it will be much easier for the microorganism to fight it. Okay, it will be much easier for for the lymphocytes to produce the antibodies. Yes, and they will produce them very fast. There is a graph there in one of our pictures. Uh, could that happen? All these things I have explained with just injecting in the body of an organism, in the body, the antigen of an organism? Well, it could. It could. Talking about coronavirus, and this is just for closing, talking about the coronavirus, they are preparing a vaccine because the vaccine has to be produced in a very delicate way. You're going to inject a microorganism, pieces of a microorganism, or a dead microorganism into the body, but it doesn't have to produce the disease. And on the other hand, not always the army works in the same way. Yes, the same as in real life. Not all bad people can be caught by the police or by the army. Not all the enemies can be fought properly. Okay, so that is what makes so difficult to make a vaccine. But that we can discuss it together in the meet that we might have this or next week. I hope you understood this. I hope I haven't been too much of a clown, and I hope seeing you very soon. So enjoy these days at home, especially these lovely days, sunny days, and try not to sleep too late. Bye bye.